NASA lost the Mars Climate Orbiter just minutes before it was supposed to begin its actual mission. After 9 months in space, everything appeared to be going according to plan. The spacecraft had reached Mars and was about to enter orbit, where it would spend the next several years studying the planet's atmosphere. Instead, it disappeared, and contact was never restored. Most people have heard that the spacecraft was lost because of a mix-up with measurement units. That's true, but only partly. When NASA completed its investigation, it became clear that the problem wasn't just the units themselves. The real issue was a breakdown in the entire mission management process. So let's start from the beginning. Mars Climate Orbiter launched on December 11, 1998, from Cape Canaveral. It was part of NASA's Mars Surveyor 98 program, which aimed to explore Mars using relatively low-cost missions. The spacecraft weighed about 630 kilograms and cost roughly $125 million. Its primary objective was to study the Martian atmosphere by observing clouds, dust storms, temperatures, and water vapor. It was also supposed to serve as a communications relay for another spacecraft, Mars Polar Lander, which was scheduled to land on Mars a few months later. The launch went exactly as planned, and the spacecraft began its 9-month journey to Mars. During the cruise phase, it performed several small trajectory correction maneuvers. That's completely normal. No spacecraft follows its planned path perfectly, so small thrusters are fired from time to make minor adjustments. This is where the problem began. The software developed by Lockheed Martin calculated the impulses generated by the spacecraft's thrusters using imperial units, specifically pound-force seconds. NASA's navigation software, however, assumed those same values were expressed in metric units, specifically Newton seconds. Those two units are not equivalent. 1 pound-force equals about 4.45 newtons. As a result, the navigation software was working with incorrect data. The mistake wasn't dramatic at first. Each individual correction was only slightly off, but there were many of them. With every maneuver, the spacecraft drifted a little farther away from its intended trajectory. Over the course of 9 months, those small errors gradually accumulated. Interestingly, engineers did notice that the spacecraft wasn't exactly where their calculations predicted it should be. However, the discrepancies were considered small enough to fall within acceptable limits and were attributed to other factors. No one realized that the underlying problem was a mismatch in measurement units. On September 23, 1999, Mars Climate Orbiter finally reached Mars. The most critical phase of the mission was about to begin. The spacecraft was supposed to pass behind Mars, fire its main engine, slow down, and be captured by the planet's gravity. According to the mission plan, it was expected to pass about 140 to 150 kilometers above the Martian surface. That altitude was low enough to begin a technique called aerobraking, using the upper atmosphere to gradually lower its orbit while still remaining safe. But Mars Climate Orbiter flew much lower than expected. According to NASA's post-mission analysis, it likely passed only about 57 kilometers above the surface. At that altitude, the Martian atmosphere was already too dense. The most likely scenario is that the spacecraft lost control, suffered structural damage due to aerodynamic forces and extreme heating, and was destroyed. A less likely possibility is that it skimmed through the atmosphere and escaped into an orbit around the Sun. However, NASA concluded that destruction in the Martian atmosphere was by far the most probable outcome. Once the investigation was complete, it became obvious that the story couldn't simply be reduced to someone mixed up the units. NASA's official report identified several additional failures. There was no effective verification of the data exchanged between Lockheed Martin and NASA. The mismatch in measurement units was never detected despite existing procedures. The growing navigation errors were not investigated thoroughly. Communication between different engineering teams was also inadequate. In other words, a single mistake should never have been enough to destroy an entire mission. It only became a disaster because multiple layers of oversight failed at the same time. The consequences were significant. NASA lost a spacecraft worth approximately $125 million, and Mars Polar Lander lost its planned communications relay. Even worse, just a few months later, Mars Polar Lander itself was also lost during its landing attempt for completely unrelated reasons. It marked one of the most difficult periods in NASA's Mars exploration program. Following these failures, NASA introduced major changes. Mission procedures were revised, software interfaces received stricter verification, and much greater attention was given to unit consistency, software testing, and communication between engineering teams. Today, the Mars Climate Orbiter is still studied in engineering schools and systems engineering courses around the world. Not because someone didn't know the difference between pounds and newtons, but because even a small mistake can destroy an entire mission when every opportunity to catch it is missed. And that's why Mars Climate Orbiter remains one of the most famous engineering failures in the history of space exploration.